All right. So let's get rolling here. So what we were just talking about local here in the classroom before class started, for those of you who are online, as we were kind of talking about well, stuff with the NBA All-Star game, watching it again in VR and stuff over the weekend, but that led to a question about, does that create difficulties when you're trying to create you can make in fact, the native way of making VR applications for the Meta Quest is Unity. You use Unity for doing that. You could also do it with Unreal, but Unity has the most support. Um, the native way of making applications for the Apple Vision Pro, which really is not an identical product to the Quest 3. The Vision Pro is, they call it spatial computing, so it's more of an idea of having stuff surrounding you. You have a announcement, CS Club announcement.
Next Monday, next Monday, we are having a senior discussion panel where we're going to tell you about like what it's like to go through the program, answer your questions you might have about like, am I actually going to use this? We're going to have food there, so please register so we know how much food to get. So thank you, appreciate it. Thanks, Lemon.
Yep. Yeah, so in any case, the goal of the Apple Vision Pro, besides just being super expensive, is that I think they originally wanted it to be a standalone device where it could do everything itself, but have spatial computing. So, I have one, I'm in it pretty often. I write software for all these things, but like if I were to wear it everywhere in my house, I can set up, for instance, next to my coffee pot, I can put like news up there so I can be standing there drinking my coffee and looking at news, which I often do, that kind of thing, but I don't always go and run to grab my headset when I'm just going to get coffee. But you can effectively set up computing stuff in your space wherever it is. It's not really designed for games, so it's not, there are immersive things inside of it, but most of those things are things that Apple created. So there's some immersive shows they have like on Apple TV Plus, which are actually ridiculous. Whatever. I mean, I'm guessing these are cameras that nobody can buy. This is just Apple made the best cameras that exist for capturing, immersive content, and it's stupid. Their latest one is like rodeo bull riding or something like that. I think I broke an arm watching it, but they have a lot of cool stuff on there. But in any case, its focus is more on spatial stuff, not so much immersive stuff. Um, and like there's a tutorial that you could make where you can like with augmented reality, you see this room the way I'm seeing it right here, but maybe there's like this thing here in the middle of the room that isn't really there, but it's built in. And this is like a 25-minute tutorial using Apple tools to make this, where they created 4 different skyboxes and they put it inside of um, uh, that thing we made. And the Apple has something called Reality Kit. Well, it's called Reality Composer Pro, I think, which generates stuff for what's called Reality Kit. And from our perspective in here, we can think of that as being kind of like Unity. So you go in there, you create a transform. They have their own names for things. Instead of a game object, it's called an entity. Yada yada yada. So you built this thing here out of a couple of cubes or whatever, and then he used some AI website to go and create, I think, 4 different like skyboxes. One of them was like clouds and stuff like that. Another one was like a desert scene. Another one was a mountain scene or whatever. And he set them up as children of that those game objects. So those entities lived inside of that guy. We saw when we were working with this stuff, if you created a game object and you made something a child of that game object, whenever you moved the game object, the top level one, everything else would move around with it. Same thing's true there. So in like 20 minutes, you could create this augmented reality for the Vision Pro where you had this thing sitting in the middle of my living room and I could walk around it and you're just peeking in the window and you can see this whole nother world that's in there just with creating skyboxes. Just kind of really amazing how good Apple's development stuff is as long as you're writing crap for their own stuff. Okay, which there's not that many people running around with $4,000 Vision Pro headsets. Now, where things could be going with this, we'll see what timing is I think that these headsets are out there now for building the content, but once Apple has basically a pair of glasses you can put on that maybe has a the power puck going in your pocket for electricity and also maybe some computation power. And you could walk around and see augments that people have put in the world, maybe for $500, something like that. That might make more sense. Go ahead.
Like the Meta Ray-Ban.
Yeah, but those are, I mean, yes, but uh, the Meta Ray Bans are really just kind of I guess I would maybe say almost like a money grab type thing, a little bit of video or image type stuff. It doesn't really have a goal in mind. It's not really linked to Meta Quest's VR type stuff. Um, but I think Apple tends to be a little bit longer looking stuff, and they're not really pushed by industry to change beyond that. But it actually, from a developer perspective and where this was going, it was asked, well, what if I want to use Unity to make an application that'll run on both the Vision Pro as well as the Meta Quest? You can do it. Apple might not approve it in their app store because Apple basically says if whatever app you wrote would make sense on Meta, we're not approving it. It's a I don't know, conflict of interest, I guess, whatever. Same reason why none of Google's stuff is available in MetaQuest. I'm sorry, none of Google stuff is available in the Apple Vision Pro. So you can't watch YouTube natively. Because whenever I'm looking at like 360 travel videos, I have to put the Quest on to go in. And some of those are really, really cool. And they're free on YouTube VR. But in any case, when you're using Unity to build cross-platform applications like that, you have to look at what libraries run on both of them. So there's a library called OpenXR, which allows the Vision Pro, call it supports-ish. The Quest 3 fully supports. So now you're trying to build this single Unity project that supports both of those. And you can have different build settings, one for the Apple Vision Pro and one for the, in fact, I can even bring this up here. Let me just go into my Unity here real quick. So what I'm trying to build here is a cross-platform kind of virtual meeting area. You know, I do a lot of VR meetings inside something called workspaces on the Quest, where anybody who has a Quest that's in my one of my companies, we join in this central room, and we see each other's avatars and can chat and share our screens and all that stuff without having to physically be in the same place. But I use my Vision Pro 95% of the time and only put my Quest on when it's something I can't do in the Vision Pro. Because hardware-wise, the Vision Pro is just better. But software-wise, and this is kind of where computer science starts, I guess, becoming fun, just because something has better hardware doesn't mean that it's going to be better if the software and something else is significantly better and the hardware is good enough. And I'd almost say that's where things kind of are between the Quest and the Vision Pro. But here in Unity, we didn't have to do this for any of our projects because you're building it for the computer you're on. So if you were doing this for Windows, it defaulted to I'm making a game for Windows. If you're doing this on Mac, I'm making a game for Mac. You weren't targeting these specialized things that had to put the camera from a person, your own perspective, things like that. But if you had to do it, you can go under build profiles in here. I don't know if I can make that any bigger. And if you're writing for the Quest, you would set this up under your Android build profile. If you're making this for the Vision Pro, I created a new Vision Pro profile here. But what was interesting in doing this is you had to go through and kind of set up for that device and the number of things you have to turn off on the Quest to make it runnable. It was kind of like, again, the Quest, I would say, has a far superior ecosystem and operating system for VR if you want to have shared VR experiences with people or anything immersive. If you're looking at using it as an individual productivity tool, like the only time I ever use my computer without my headset on is here when I'm sitting here. And I think last semester, didn't I bring my Vision Pro and do one class with it on, I think. But in any case, usually I put my headset on, this screen goes black, and I get a movie screen with my computer screen because I have bad eyes. So that's great for me. But that's mostly what I use it for. Otherwise, I'm watching Netflix or Amazon Prime, whatever. I'm watching shows and crap like this. A movie theater. One Whereas I put the Quest on for everything else if I want to watch immersive videos or whatever. But just building for these two different things, trying to create a single project that targets both of them through OpenXR. So like for the Quest, if I go in here, you have to go and select a bunch of different things underneath. It's an edit project settings. Down here, we had to add something called the XR plugin. And you see that for this, you have settings for the Vision Pro, which you don't get to change anything for. It's just like, hey, we have crappy Vision Pro compatibility and you don't get to pick anything. It's not that crappy. It's mediocre. But for the Quest, you can pick which things you want to use on it. And then once you get down into the individual things like OpenXR, that's where you can start saying, I want to have foveated rendering, which means only put your GPU horsepower into what you're looking at. If there's something over here, you can make it blurry because we're not staring at it, that type of thing. Again, the Vision Pro has no settings. Just kind of an entertaining thing, but I'll tell you what, to get a single project that launches a scene that looks the same in both the Vision Pro starting point and the Quest 3 starting point was like pulling teeth. Yeah, it was fun, but you really lets you feel the difference in those ecosystems when you're going through it, and you're using Quest to do it. What's cool with the Quest 3 for development, because even if you're developing with Unity for the Vision Pro, when you want to go and build it, it takes probably, I don't know, 30 seconds or so to build it in Unity. This is a fast computer. This is as fast of a computer as you're going to get for doing any sort of Apple development. So it takes 30 seconds or so to build this in Unity. Then it opens it up in Xcode, which is Apple's development thing, because it creates an Xcode project for you. Then you have to build it in there. That's another like 4 minutes to build and install onto the device. Okay. Then you find out it didn't work. It's infuriating. Whereas with the Quest 3, if you use the built-in stuff for Quest 3 with Unity, you could just hit the play button and poof, it pops up in your Quest 3. And since I'd probably be using my Quest 3 to use my computer in VR anyways, you can just do that whole thing inside of VR. It's a pretty neat development environment, but since I have both, I'm picky, and the text is just a little bit fuzzy when I'm using my computer on the Quest 3, where it looks perfect on the Vision Pro. So I use my Quest 3 as a bath mat for most of the time. Interesting geek stuff related to Unity, but that will come up if you want to move this away from VR for you, and you're thinking about what if I want to write games for PlayStation or Xbox or these different consoles. You might have to jump through very similar hoops. Xbox and PlayStation use different online gaming things, and you might have to implement something twice in order to have multiplayer games on PlayStation versus multiplayer games on Xbox, which is why for some of you who are gamers, it's not super common to have a game that's online where you can cross-platform with Xbox and PlayStation people inside of one game. A lot of times they're segregated among people in those games, and that became a development challenge for them. It's not impossible, but it probably required another server in the middle that did the crosstalk between the two things. I guess interesting stuff. All right. So what I'm going to do here is we're going to start a new project, because we're going to start integrating our dungeon stuff into this. And we want to start with a kind of a little mechanical thing where we want to have 4 doors, because we have possibly 4 exits in a room, right? North, south, east, west. And we want to have the ability to programmatically have those doors show up or not show up, depending on whether or not they're an open door in that direction or not. Okay, just kind of doing stuff the Unity way. So this is nothing new. It's just we're now applying it to something we were already working on in class. So I'm going to create a new project. I'm going to choose Universal 3D. Notice they do have, if you want to do VR, you can do a VR core thing, but if you're going to do cross-platform VR, don't click that. You'll waste 2 hours. is what will happen, and you'll end up deleting everything they gave you. But we're not doing VR, we're just doing normal whatever. So choose universal 3D. If you want, you could choose high definition 3D, but we're not going to have high definition graphics, at least not in mine. So we're going to call this guy CSC 2050 Spring 2025 Dungeon Crawler. All right, and where's this putting that? I'm gonna put this inside of this directory for me. Do I have a Unity folder? Let me just create a Unity folder. All right, so throw it in a place on your computer where you'll be able to find it. You can say connect to Unity Cloud. You could use Unity version control, but you don't have to for right now. None of this matters. Just leave everything the way it was. Just make sure you're storing it in a place you can find. Click create project. It's going to go and do its whatever. One thing you'll notice if you haven't already done so, if you're used to using your laptop with the trackpad or whatever, you will notice that as you get further and further into Unity, you might find it handy to have a mouse that allows you to grab things. You can actually pull it off with the trackpad somewhat easily, but the mouse allows you to kind of rotate stuff much better. So I basically keep a single Bluetooth mouse in my laptop bag for when I do Unity stuff. Otherwise, I don't use a mouse on my computer for anything. Okay, so when I first launched this, let me make sure everybody's in already. Okay, and let me just hide those meeting controls. Okay, so I usually, when it first starts up, I just hit play, make sure everything is working with my base setup. They give us a sample scene and that has a camera and some light and all that stuff initially. Game is running. We see it running down here. Looks beautiful, whatever. All right, so everything is currently working. So now we want to go ahead and actually what I'll do, let's just use our sample scene. I'm going to rename this guy. Actually, does it let me rename it? Well, whatever. Okay, so we're going to build our room here. So I'm going to start off by adding a 3D plane. It's going to be our ground in our room. Very similar to what you did for your the rollerball thing. So we'll call that ground. You know, I'm going to just make this guy 10 by 10 on the Z. Probably actually doesn't need to be that big. Probably 2 by 2 is probably good enough because we really want this to represent like a single room. We might make it a little bit bigger here in a second. Okay, so then we might create some material so our floor is not just plain white. So we'll go back here to my assets folder. I think if I double click that, does it open it up here? No, whatever. So inside my assets folder, I'm going to go ahead and I'm going to create a folder called materials. You don't have to put stuff in a folder. You can have everything inside of your assets folder all just piled up there if you want. Won't look good. So folders are for for us. All right, so I'll go into the materials folder. I'm going to create a new material. And we're just going to call this guy floor. And I'm going to change its color to, I don't know, black. Good enough. All right, we'll take that material, we'll drag it onto the floor. Now we have a black. All right, so before we get where I'm not going to put walls up yet, you can always add those now. Basically, what I'm going to do is I'm going to put 4 doors into the scene. All right, so probably I'm just going to create an empty game object here. We'll call this guy doors. Now, based on what we have available to us, a door is probably a cube that we've just kind of shaped into a door-like thing. So inside of my doors game object, I'll go ahead and I'll create a 3D object. I'm going to create a cube. All right, so there's my so we'll call this guy door west. Guess we have to kind of decide what west means, but whatever. All right, so we'll have door west. Currently, it is in the middle of the screen. We'll go ahead and just lift it up so it's above the ground at 0.5. So now it's just sitting on the ground here. All right, if I want to move it over towards one of the sides, I can do that. Frame it. All right. So we might make it a little bit taller. So maybe we decide it's a 2 on that scale, which means we'll have to lift it up by 1 to have it sitting on the ground. Maybe we make it a little bit skinnier so we can click on this thing. There is a, what is it? This one here is the everything. Or is this one the everything? Transform tool. So you can use the transform tool that gives you the ninja for everything. If you want, I tend not to use that because I have trouble clicking on stuff so I usually would just select the right thing. I want to scale this. So I'm going to make it a little thinner that way to be a door here. So that made it, so I'll just call it 0.2 for my width. Then we'll drag it right there-ish. We'll just say that that's perfectly placed at this point. All right, so now I can go ahead and I can create 4 more or 3 more doors. So I'll go ahead and just duplicate that 3 more times. We'll create a door north and door north. I'm going to, here, I'm going to go like this, zoom out. So so actually this, my door west is actually on the east side right now, based on looking straight down. So I'll just move that guy over-ish. My door north, I'll move him up here-ish. And then we need to rotate him a little bit, but we'll come back to that. Door east. That's already in the right place. And then door south. Okay, and we will put that guy here. Move him here. Whatever-ish. All right, then we'll go ahead and rotate those doors. So I'll start turning it here. And I'm seeing it move up here on the Y, so I'll make that 90. Guess it didn't matter if I did negative or positive, which side of the door I'm looking at. All right, so now I have 4 doors. I'm going to go ahead and I'm going to move my camera a little bit so I can kind of look down on the scene instead of out on the scene as we're testing this. So my camera, I'm going to change its position to 0, 0, 0. So put it right here in the center of the screen. I'm going to go ahead and put it up in the sky a little bit more. So let's put it like at 5 on the Y. And I'm going to come over here to the side so I can see it. And what I want to do is I want to drag it to look down towards the ground. So you just start dragging it. It shows you what it's going to look like here. So then I can finish the 90. Put a little higher up. So let's make it 10, maybe 20. Perfect. We can see all of our doors. All right. So this just comes with practice with this thing. And mean, I don't have super strong 3D skills, but I can do this. I got 4 doors and I'm looking at them from straight down, and I just had to rotate my camera down to look at the scene. All right, so now what we want to be able to do as we start incorporating our dungeon here is we want to be able to programmatically say whether we want one of these doors to appear or not appear. Okay, so kind of a door controller. Now we can decide how we want to handle that. We can have an individual door that has a script attached to it, and that individual door could just have, maybe it checks with a singleton and says, should I be showing up or not? So we can put so this is kind of thinking about it from a game design perspective. Do you want doors themselves to decide whether or not they should be shown or not? Or do you want to have kind of a single game manager inside of our game that is in charge of all the doors, and he can turn them on or off as he wants? These are kind of choices that you get to make as a programmer. All right. Now, the side effect of this might be if you say each individual door is in charge of whether or not they are turned on or not. That means that they would have, each of them would have a start function, and potentially the doors would also have an update and know if something collided with them. Ultimately, we're probably going to have a player that's going to be in here, and he's going to be moving towards one of the doors. And if the player has a collider on them, they might bump into the door to the north. And what that would do is it would put them in the next room. And then the doors would update based on what available exits there are in that next room, that kind of thing. Okay, so we can think ahead a little bit. So for now, why don't we go ahead and create a single game object that's in charge of the 4 doors rather than putting a script on each of the doors. So I'll just go ahead for right now. I'll minimize that doors thing. I'm going to go in here. I'm going to create an empty game object. We'll call this guy the room manager. So this guy's entire existence is about making sure that the room is behaving the way it's supposed to behave. All right. Now in a script, he's probably going to need access to those doors. All right. So we're going to go into our assets. We're going to create another folder for our scripts. We'll go into that scripts folder. We'll create a mono behavior script. And why don't we call this guy room manager? Okay. I'll go ahead and double click on this. It'll open up the code. First time it opens up inside of VS Code, you say, yes, I trust myself. Go ahead and expand this out some. All right, big enough. You can see the code. This is Visual Studio Code, which is a different product than Visual Studio. Visual Studio Code is kind of a scripting tool for many programming languages, where Visual Studio can be used for other languages, but it's largely a full development environment that also allows you to build graphical user interfaces for .NET websites as well as like Windows .NET applications. So if you're not building those types of things, you're just doing coding stuff, Visual Studio Code is a lighter weight option. And it's much more mature now than it used to be. So Visual Studio Code, I think, probably came out 3 or 4 years ago. Early on, it was not the greatest tool, but now it's got a zillion plugins and stuff. It's pretty good. That works for almost anything. I often run into situations with VS Code where I want to do it in some old school way that, you know, because I've been doing this for a long time, and it finally is yelling at me enough times about installing some plugin that I finally do it, then realize like, oh, this is so much better. so yeah, I don't know. It's just kind of an interesting thing when you are set in your ways and you think you have your process. I still find myself out of the terminal sometimes for any of you Linux users. I use the VI text editor often. If you don't know what I'm talking about, that's probably a good thing. But back in the day when you didn't even have a mouse, everything was a command line text editor. And like to save the file, you would have to do Shift colon WQ for write quit. So you actually give commands to your text editor. You get used to doing it, so it sounds like it'd be inconvenient, but it happens really quickly. But there is a better way for today's society, and that's tools like this. All right, so our room manager, we've decided that likely there's going to be other things that the room manager has to control related to our room, right? But at the very least, for right now, we wanted to control 4 doors, which are game objects, right? So we can choose to treat them as game objects. We can choose to treat them as transforms if we want. I'm going to treat them as game objects. If it's a transform, then you're only getting the transform component of the game object, even though Unity sort of kind of makes a very blurry connection between a transform and a game object. So even if you have the transform, you can get other components. I think you saw that in the tutorial where you had the group of transforms for your collectibles. Instead of it being an array of transforms, an array of game objects, it was an array of transforms, and you could still get the rigid body from those. I like using game objects, so I guess a deal. So we're going to create this to be public because we want it to be exposed to the Unity editor. All right, and we're going to create a game object array. We'll call this the doors. All right. So make sure you save your script. So now I need to now go connect up my doors to this guy. Now I didn't give this guy a size yet because I'm fully expecting him to get set from the Unity editor. This is MVC, Model View Controller. Okay, we're keeping our code in one place. We're keeping our interface in a separate place. So I'll go back into Unity. I'll click on my room manager here. I'm going to go ahead and expand my doors. We'll go ahead and drag this script into my room manager. So now my room manager has the room manager script component. And we see here that he has a drop down for doors. I'm actually interested in whether they've added this. Oh, sorry. No. Oh, what happens if I click that? No, didn't work. So I'll go ahead and create 4 landing spots for my doors. And why don't we just put them in there, the order north, south, east, west. So I'll put the north door at bucket 0. I'll put bucket 1 as the south door. Bucket 2 is the east door. Bucket 3 is the west door. All right, so now I've provided those physical game objects to my script. All right. So go back into the script here. Now, if I do nothing else, I go ahead and hit play. We're going to see that, our game runs. It looks obviously amazing. We have the light kind of reflecting off the floor on the right side for no good reason. But I didn't move the light, so I think this looks fine. So, but in any case, we see all 4 doors. So now what we want to do is we want to say, well, if I want, let's just try to turn the north door off. Now we know that the north door is at bucket 0 because that's where we put it, right? All right. So if I go and click on the north door, we want to ask ourselves, how do I turn this off? How do I either disable the entire thing or not make it show up? Whatever we decide turning it off means to us. And this will become clearer as you get deeper into making games where, there's a difference between something not being able to be visually seen and for it not to be there. So for instance, if I turn off the mesh renderer for my north door, we see it disappeared. But he's still there. That north door is still positioned in that location, which means that unless they've programmatically done this, you could still bump into something that's invisible. The box collider is still enabled. So sometimes you have to mess with the mechanism by which you want to accomplish what you're trying to accomplish the correct way. Sometimes what people do is instead of turning things on or off, if they just want to make sure it's out of play, they'll just update the position to put it a mile up in the sky. So just don't look up. So sometimes you can see that when you're working in VR applications for like the Quest 3, when you see somebody like making one of these indie games, you'll sometimes look up and you'll see stuff floating around up there because they didn't put it above the ceiling, or you're in kind of an open world thing, whatever it is. All right, but for us, we'll say, you know what, the mesh renderer is probably good enough. We could also just disable the entire thing, so I can just click on this is the whole game object, and that would just make the game object as if it's not there. So let's look at those two options. So I'll go into my code. We'll go ahead and put this inside of start, since this happens only one time. And we know that the first thing is the north door. So we'll say this dot the doors at bucket 0 dot, is it enabled? Set active to false. So that will turn that game object off completely. It does not exist in the scene at that point. Go ahead and save that. Before I hit run, this is what our initial setup looks like with the north door being there. I'll go ahead and run this guy, and we see he's now gone. All right, similarly, if we didn't want to turn off the entire game object, this is again kind of doing exercises, kind of feeling out how this stuff works. I can say, well, as I've experimented with it over here, I see that if I disable the mesh renderer, just that one component, I also can make it disappear. So how would I get at the mesh renderer inside of Start? Well, I go into my code. I'll just comment this out for a moment. And I might say, okay, I want to create a mesh renderer, MR, and this is going to be equal to this dot the doors at bucket 0. That guy is a game object, right? And we'll say that get component, and the component we want is the mesh renderer. So then we could take our mesh renderer and set its enabled to false. So game object still on the scene. We've just kind of put the invisibility cloak on it by turning off the mesh renderer. All right, so this is how we can take a game object, get one of the specific components of that game object. In our case here, we're getting this component right here. This mesh renderer of door north, which is at bucket 0 of our room manager script. All right. So we're getting that mesh renderer, and then we're saying, I want you to set yourself to be disabled. Make sure you save your script. If you switch back over, you'll see Unity automatically rebuilds. We'll go ahead and run this. And we see that it has also disappeared. All right. So now what I'm going to do is I'm going to right click here in my scripts folder. And actually what I'm going to do is I'm going to put it in this folder. Let's create another folder in here, and let's just call this guy objects. The idea here is I want this to be where I keep my non-mono behaviors. So right now, when you're in Unity and you create a script, it always, always, always makes that script a mono behavior. And what does mono behavior say? It says, I now participate in the game loop, which means that the start function gets called once, and then the update or similar function, if you use fixed update or whatever, gets called every frame or 60 times a second, whatever it is. Okay. We want some of our stuff to be not mono behaviors. We want them to be plain Jane object-oriented pieces of code. So what I'm going to do here is I'll go into that objects folder. We'll right click. We're going to create. Our only option here is a mono behavior script. So I'm going to do that. And I'm going to name that guy core, like we named our singleton and our other projects back in Java. I'll go ahead and double click on that guy. And I'm just going to take off the mono behaviorness of that guy. So right away, it starts looking a lot more like a Java class, almost immediately, right? Remember back when I told you that Java, C#, basically the same language. All right. So that means that this core here won't have a start function that automatically gets called. It also won't have an update function that automatically gets called. So we might as well dump those guys because we don't need them. All right. I want this guy to behave like a singleton. So I'm going to go ahead and I'm going to create a static variable. Let's make it a Boolean. So it's bool in C#. And let's call it north door. And we'll set this to false currently. And we can do this for our other doors too if you want, but guess whose homework that's going to be. All right, so we'll just have this thing up at our singleton. And now what I want to do is inside of my room manager, what I'm going to do is we'll do what the whole game object instead of the mesh renderer. So I'll get rid of those two lines right there. And I'll just go back to my game object one. And instead of setting my doors at bucket 0 set active to guaranteed false, I'll set it equal to, what did I name my variable here? North door. Ooh. I think that should link when we actually run it. It doesn't think it knows about it right now. Do I need to make it public? Yeah, that was it. That's not a C# thing. That's a Unity thing. Unity says if you want to be able to access code that is not a mono behavior, make it public because the way it houses that is kind of in a different namespace is the C# way of handling that. But from our perspective, just make it public. So now I'm just setting my door at bucket 0 to whatever core.north door says it should be, on or off, that kind of thing. So as it stands right now, I have set it to false. So that means it should be turned off when I run my game. Go ahead and do that. So now it's off. If I go in, I just modify core and I set that to true instead. Go back into my game, hit play. Now it'll be there. So now we are controlling whether or not that door shows up based on the variable that is inside of my singleton. Make sense? So I can fully control that. So what we want to do for homework to keep practicing here is we're going to say start a new Unity project for our dungeon. Name it whatever you want. You're basically doing exactly what I did, except you're going to expand it to work for all the doors. So again, getting practice using Unity after a couple of assignments, you'll be able to zip around Unity. Who, what? Well, what stuff? The code I did today? Well, I can paste it up there. Sure. Here, just so I don't forget. This is the entire core file. So if I come into Unity, I think I can choose is this the code block? So we'll put that up there. I'll say, yeah, whatever. That's class core, and here's my room manager. All right. So those are the two scripts that you have right now. Not a whole lot going on in those scripts at this point. All right, so create a dungeon room as you see fit, with up to, well, let's call it with 4 doors that have the ability to be hidden or unhidden. Let's just assume that's a thing. Based on the current state of the core. Oh, I don't know how to spell. That's fine. Core singleton. All right, so just like we've done now, but we should add the ability to have all 4 doors turn on or off. All right, so what you would do to test this is go in, change core before you run the program. A couple of doors should be true, a couple of doors should be false. Go back and make sure that when you run your program, that's what happens. And then you'll kind of know that I have control over my room. What we're going to do when we come back on Wednesday is we're going to start bringing our data structures that we wrote inside of Java, like our room data structure, things like that, our dungeon, and bring that into code here so that we can keep track of where is the player currently in our dungeon programmatically, because what's going to happen is that as our player goes from room to room to room, all we're going to do is change the configuration of our current room and then show the player moving into that room from the opposite door. If they go to the north, you'll see them enter from the south, with the new doors showing up or not showing up, that kind of thing. All right, so I'm just going to say submit. Your C# scripts along with the self-assessment. All right, questions, comments, concerns, bribes? All right, I'll see everybody on Wednesday. I'll get this assignment up here now. Sure. Well, I don't care. I don't know. Take them. I don't know anything about them. So if you're gone, I'm not going to miss them. Room manager was an empty game object, but the script was a mono behavior. I made it a public game object array.
Yeah, sorry, the doors themselves, if you put them inside as a.
I didn't do them as a prefab. You could make a door a prefab, but right now doors are just strictly visual thingies. So I just created an empty game object called doors, and then I put 4 other cube game objects that I sized the same, positioned them on the screen. I just put them as children under there. That way I can just do that, and all my doors are inside that little folder. Yeah. Cool. 1 second, let me get the video converting.